Hello everyone. Now let's talk about fan coil unit, a very basic arrangement that we should all be familiar about. By now we have seen fan coil unit in your day-to-day life. However, let's have a deeper look into fan coil unit and its arrangement. It is very basic, a single chamber arrangement in a fan coil unit. As name suggests, we have fan. So fan is a must to make the airflow happen. And depending on the scenario, in most cases, we have cooling coil or heating coil or both of them. So depending on the scenarios, maybe heating coil is enough, or maybe cooling coil is enough, or maybe in certain scenario, we might need both of them. Usually in hot and humid climates, we only prefer cooling coil. And in winter-based countries like Canada and other Nordic countries, heating coil is required. And sometimes, if you're facing extremely cold and extremely hot weather in the same place, you might go for both cooling coil and heating coil, depending on the scenario. But in most cases, only one coil is enough. It is only one chamber arrangement. There are no multiple chambers. So inside a chamber, there's a fan and there are coils or heat exchangers. The fan can be in front of the coils or can be backward, like in this place. There are different types of fan coil arrangements, different type of units. So if you look inside, it's a typical one. There is a coil, and here is your fan motors, the blowers. So air is sucked in and fallen through like this. And there is a drain pan to collect the condensation. This type of unit is actually ducted type unit. So there are many types. Basically, depending on the installation, based on the installation, we have four different types. One is the ceiling concealed, the ducted one. So earlier, the picture we have seen, that one is ceiling concealed, ducted one. And we have the ceiling exposed, like regular cassette unit, or we have the wall mounted unit. These are also FCU, or we can have floor mounted unit. So depending on our requirement, we can use either of them. So mechanism wise, all of them works in the same principle. There's a fan, there's a coil, and refrigerant, hot or cold, flows through the heat exchanger coil, and air either gets heated or gets cooled down. Based on pipeline, we may have two pipe system or we may have four pipe system. For instance, if we have only one coil arrangement, let's say if we need only cooling coil only, then we have two pipe system. One pipe is bringing the cold refrigerant and the other pipe is taking out the collection. And in case we have both cooling and heating requirement, and in that case we need both chilled water as well as hot water, or chilled refrigerant as well as hot refrigerant. So in that case, we have four pipes arrangement like this one. So there is a cooling coil here, cooling coil, and the refrigerant, the chilled water, for instance, is coming through this pipe and going out through this. And the other one is for heating coil. Heating coil is in here, AC. So hot water is coming through this pipeline and going away like this. So based on pipe system, we have two types, two pipe system and four pipe system. Based on airflow direction, we have two different types. One is draw through, another one is blow through. Well, let's learn about this draw through and blow through. What is happening here is like we have a fan and we have the heating coil or cooling coil. So if the air is blown through the coil, we call them blow through. So for instance, here is a fan and the air is blown through the heat exchangers. Now it is a blow through fan, a blow through unit. Draw through. Draw through unit is like the heat exchanger here, and the fan coil unit is in here. So if air is drawn like in this pattern, drawn through the heat exchanger, we call this draw through arrangement. Okay, let's learn about some pro and cons about both draw through and blow through arrangement. Air movement wise, draw through, fan draws air through the cooling coil. So here's the fan and the air is drawn through the cooling coil. The direction is from right to left like this one. Blow through, fan blows air through the cooling coil. So there's a fan from left to right. Air is blown through the cooling coil. So direction is different. Cooling performance, draw through provides uniform airflow and better cooling distribution. Blow through may have hot cold spots, slightly lower efficiency. Air filtration wise, better filtration and air passes through the passes filter than coil. Filtration not always as effective as like the draw through fan coil unit. Fan location, fan is after cooling coil. When it comes to draw through, the fan is after cooling coil. When it comes to blow through, fan is before cooling coil. Cost competency, slightly more expensive and complex. Simple and cheaper. So draw through is slightly more expensive and complex. It is not that complex actually. Blow through, simple and cheaper. So usually in most cases, draw through is what we suggest. Okay, let's look at what fan coil unit can do, can control. Remember, in very first chapter, we have learned parameters of air, what we can control through HVAC system. Let's check what fan coil unit can control. Temperature, fan coil unit can control the temperature, but to do so, the fan coil unit must have both cooling coil and heating coil, both of them. If both heating coil and cooling coil is available in the fan coil unit, and supply of hot water and chilled water, both of them are there, it can effectively control temperature. However, in most cases, if you are living in a hot and humid country, usually you have only cooling coil. In that case, fan coil unit cannot control the temperature. It can lower down the temperature, but it cannot increase. So basically, when we say controlling temperature, it means fan coil unit should be effectively bring down the temperature, as well as it should be available to bring the temperature up. For instance, let's say this is your space and you have a fan coil unit here inside. Inside, if your requirement is 22 degrees centigrade, the fan coil unit must be able to meet this temperature if it is effectively controlling the temperature, irrespective of ambient condition. If ambient condition is 32 degrees centigrade, it can bring it down to 22 degrees centigrade. And if the ambient is like, let's say 15 degrees centigrade, it can bring it up to 22 degrees centigrade. And it is only possible if fan coil unit have both cooling coil and heating coil. If it has only cooling coil or only heating coil, this operation is not possible. In that scenario, fan coil unit will not be effectively controlling the temperature. Humidity. Humidity, usually we do not use fan coil unit to control humidity. It is not required. But If you have both cooling coil and heating coil available, it can effectively do so, but usually we do not use this fan coil unit to control humidity. Fresh air, fan coil unit is only one chamber. It has a supply and return. There is no chamber for fresh air connection connectivity, so it doesn't control the fresh air. Supply air, obviously, it controls. Return air, yes, it does. Air pressure, well, fan coil unit by theory can control air pressure. However, in places where we need to control air pressure, we usually use AHU, air handling unit, rather than fan coil unit. So fan coil unit may effectively control air pressure, but usually do not use fan coil unit to do the control. Okay, so air particle count, obviously fan coil unit have only one chamber. We do not use this to make a highly efficient air filtration system. For that, air handling unit is a better choice. So what we see, fan coil unit, depending on the scenario, it is not available to control all the parameters of the air. It has some limitation. Where we use fan coil unit, obviously commercial space, we can use fan coil unit. Residential project, obviously. Auditorium, depend on the scenario, fan coil unit is a choice. Also, air handling unit is a choice. It has, both of them have their own pro and cons. Depending on the scenario, designer make the choice. Hospital upper OPD and patient waiting, OPD, outpatient department, patient waiting. Yes, we can use fan coil unit there. No need air handling unit. And other cooling requirements, yeah, whenever you need some cooling, you can use fan coil unit. So that's it. That's all about fan coil unit. Moving up, we're going to learn how to size a fan coil unit, the tonnage and load calculation and everything, so that you can effectively choose your fan coil unit on your scenario. Let's move forward.